Hello everyone, this is Adnan, and in this series I will be covering the entire IGCSE Cambridge Chemistry syllabus. And the course code is 0620, and I'll be covering all the topics, including core and extended. Okay, so these are the chapters that are included in the syllabus. We have 12 chapters. So this is the first video lecture of the from the series, and here we will be discussing the states of matter. And the first topic in this chapter is 1.1 solids, liquids, and gases. Just let me just give me a second. Let me just paste this diagram here. Okay. So as we already know that matter, it can be classified into three different states: solids, liquids, and gases. So the first topic is state the distinguishing properties. Let me just paste the subtopics of this chapter as well. Just give me a minute. Okay, so the first topic, it states that state the distinguishing properties of solids, liquids, and gases. So as we already know that there are three states of matter which are called solids, liquid, and gas. And for solids, particles are closely packed and they have a fixed arrangement. They cannot be compressed and all. Are close together, but they have a random arrangement and they can slide over each other. For gases, particles are spread apart and they have a random arrangement. And if you observe in your surroundings, so we can easily identify these three states of matter, right? So now the next one is describe. The keyword here is describe. The command word: describe the structure of solids, liquids, and gases in terms of particle separation, arrangement, and motion. So now for each of these three states, we will be talking about their particle separation, particle arrangement, and motion of their particles. So as we can see that in a solid state, particles hold a regular arrangement and have the least amount of energy, and the particles vibrate in fixed position. So remember that the motion here is vibrational motion, and their arrangement is regular, and yeah, and the separation, they don't have any separation, right, for solids. And for liquids, particles are arranged randomly, and they are close together, but the arrangement is random. There's no pattern here. So particles are able to move past each other and take the shape of their container, and they cannot be compressed. Both solids and liquids, they cannot be compressed. And for gases, particles are randomly arranged again, just like liquids, and they have the most kinetic energy, which I'll explain later. The particles in a gas are relatively spread out and move randomly in all directions, and since there is a gap between the particles, they can be compressed. So this is basically topic number 2. And this subtopic 3, it says describe changes in states of state in terms of melting, boiling, evaporating, freezing, and condensing, right? So now what is you know melting? So when a solid changes its state from when a substance changes its state from a solid to a liquid, so that is called melting. And when a liquid changes into a gas, that is called boiling. evaporation. So the difference between boiling and evaporation is that evaporation only occurs happens at the top layer, and it happens on all the temperatures. And boiling, occurs at a fixed temperature, and it happens all of a sudden, like all of the liquid molecules, and they will simultaneously be changing into the gaseous phase, right? They form bubbles and they rise up. Liquid particles at the bottom, they convert into gas, they form bubbles, they rise up, and very quickly all of this liquid will be changed into a gaseous state. That is boiling. And now freezing is when a liquid changes back to a solid state, and when gases, they change back into a condensation. And we have some other terms. When solid, they change directly to a gas by skipping the liquid phase. That is called sublimation. And gases can do the same. They can change directly into a solid state by skipping the liquid phase. That is called deposition, right? So these are some of the terms that we are expected to know. Okay, so as we have discussed these, now let's take a look at the next one, which says describe the changes. I think we have already talked about this. Yeah, number 4, describe the effects of temperature and pressure on the volume of a gas. Okay, so let us talk about the changes of temperature. So we should know that temperature, if we increase temperature, will also increase, because the particles, they move apart when temperature is increased, so which results in more volume. They need to occupy more space, and again, yeah, so since they are directly proportional, so if we decrease temperature, so the volume will decrease at the same time. And this is the relationship of temperature and volume of gases. So for pressure and volume, so increasing pressure decreases volume, right? Remember that. So you can imagine a flask which is connected to a movable piston, and if I apply force, if I exert pressure here, so what will happen? These gas particles, they will come closer to each other, and the volume will decrease. So this is the relationship. It is inverse relationship between pressure and between pressure and volume. Okay. So, and as pressure decreases, the volume of gas will increase. So this is the relationship between temperature, pressure, and volume of a gas. So now, at some topics from the extended syllabus, which says explain changes in states and of state in terms of kinetic particle theory, including the interpretation of heating and cooling curves. So basically, kinetic particle theory models the 3 states of matter by representing the particles as small solid spheres. It can be used to explain melting, boiling, freezing, condensing, and sublimation. So let's take a look at the let's talk a bit more in more detail about these. So why solid particles, they are held together? That is because they have very strong intermolecular forces, and that is why they are closely packed. They are holding on to each other very tightly, and that's why they cannot move, and that is why their kinetic energy, since they cannot move, their kinetic energy is very low, right? So as we increase temperature, so the intermolecular forces will start to weaken, and they will start vibrating more and more. Their kinetic energy will increase, and a time will come where they will no longer be able to hold their structure as a solid, and they will be converted into a liquid state. So now in a liquid state, the intermolecular forces are weaker as compared to the solid state, and the kinetic energy of the liquid particles is a bit higher than the kinetic energy of solids. And as we keep on heating liquid particles, their kinetic energy, increases, and the intermolecular forces are broken even further. They are weakened, and that is why. And then a point comes where the liquid particles, they change into a gaseous state, where theoretically there are no intermolecular forces, and kinetic energy is very high. And that is why they have a random arrangement, and so much space in between these particles. So now let's take a look at the heating and cooling curves. So basically what you need to understand, so let me draw a heating curve. So here, this is like this, 1 and 2. Okay, so we start in, this is time on this axis, we have time in seconds, and on this axis we have a temperature in degrees Celsius, for example. So let's say we have a solid, let's say water, for example. So water is stored at 0 degrees Celsius. So this is 10, 20, 30, all the way up to, uh, you know, okay, now I have to make a 0 here. Okay, and then this is going to be 100. All right, so since this point it is lower than 0, so water will be in a solid state here. So like let's say it's like it's in the form of ice, right? So let's say we start heating ice, so the temperature of ice will increase, and it will go all the way up to 0. And once it reaches 0, you can see that the temperature stops changing, even though we are applying, we are providing heat to the sample, but still the temperature is not rising further. Why is that? Because this is where the state changes, right? So water at 0 degrees Celsius, it melts. So this is melting. So remember that whenever states are changing, during that process, the temperature, it doesn't change, right? It will remain the same. Let's say you have ice at 0 degrees Celsius. You have a block of ice at 0 degrees Celsius, and you're heating it. So the temperature of this block of ice will not rise. So this may be surprising, but this is how actually it is. You can actually perform this experiment at home under a supervision of an adult, and you will figure it out yourself that you can put a thermometer in a beaker, in which you can take some ice cubes and you put it on a stove or a heating device, and you will see that the temperature will be very close to 0, until all the ice in that beaker, it melts, right? So once all the ice melts, it changes into a liquid state. Only then the temperature will start to rise again, right? So now the question arises that why does that, like, temperature doesn't rise, right? So the answer is that that temperature is being consumed in breaking the intermolecular forces, the intermolecular bonds, like hydrogen bonding, for example, in water. So, and it is not being absorbed by the molecules itself. That is why their kinetic energy remains the same during the state change. And once all the hydrogen bonds, or like, which is an intermolecular force, and they are broken, so only then the molecules, they start to absorb and that kinetic energy again. So again, you will see that once ice is melted, so liquid water, the temperature of the liquid water will start to rise again, and it will reach 100. And again, there here we have a state change. Water boils at 100 degrees Celsius. So this is boiling. So again, water will stop, the temperature will stop changing, right? And so here water is existing as a solid, here water existing as a liquid, and here water is existing as a gas, right? So, and then since we don't have any state after gas, so now steam can have a temperature anywhere from 100 degrees Celsius to 10,000 degrees Celsius, right? So you can keep on heating the gaseous water like steam, then there's no limit. So this is basically how we draw or represent the heating and cooling curves, right? So now we take a look at the next part. So okay, we can take a look at the cooling curve as well. So the cooling curve will be the opposite of this graph. You have to start from the highest point from here, and temperature is decreasing, then there's no change in temperature, then temperature decreasing again, then no change in temperature, and then temperature dropping again. So again we can see that this is a gaseous state. Once water comes back to 100 degrees Celsius, so it will be it will be condensing. So this is condensation, gas changing into a liquid, right? So here water, the process, the state change in condensation. And again, when all the gas changes into a liquid state, again the temperature starts to drop, and uh, you know eventually liquid water, it reaches 0 degrees Celsius, where it changes into ice, a solid state. So this is freezing. And once all of the water is frozen, so again there's no state change after water reaches a solid state. So your ice may have a temperature of negative 100 all the way up to, or maybe even lower than that, up to a negative 1 or 0. So and this is how basically the heating and cooling curves, they work, right? So the last part is explain in terms of kinetic particle theory the effects of temperature and pressure on the volume of a gas. So I've talked about it already. So as I explained, that it is all about the intermolecular forces between the particles in a solid state. Uh, just because the intermolecular forces are so strong, they are tightly packed, and that is why their kinetic energy is very low. And similarly, in a liquid state, now the intermolecular forces are a bit weaker, and kinetic energy is a bit higher as compared to the solid state. So this is how basically we explain topic 1.1.6. So this was all in this lesson. And if you have any questions, you can ask me in comments, like, subscribe, and share. And you can also join my free school community for chemistry content. And if you wish to join group lessons, you can subscribe to the premium version on the school community. And I also offer one-to-one lessons, but the seats are very limited. And if you want to join one-to-one lessons, so you can fill the form. The Google form in the description. So this will be all for today, and I will see you in the next lesson, and take care. Goodbye.